to take you through something called high bandwidth memory. All of you, I keep promising I'm not going to take any more show of hands, but I will. Everyone know what GDDR5 is? Everyone know what HBM is? I would expect most of you not to have those kind of distinctions in the front of your mind. GDDR5, graphics DDR memory, double data rate memory. Well, no big surprise, GDDR5 is going to be better than GDDR4, GDR3, etc. It's a process of development in graphics memory which has been a really big deal for the industry. We've led the way with that. We were the first company that ever shipped with GDDR5. The guy who invented it is fundamentally Joe Macri, who's our CTO on the client side. And the truth is, graphics DDR memory, GDDR stuff, has effectively run out of runway. It's as far as it can go when it comes to the best performance for a given wattage. So we have invented a new thing called high bandwidth memory. This is, like I say, the future of memory. And although I'm going to talk about it attached to a particular chip that comes from AMD, this is absolutely industry standard and is not designed only for graphics. So this will find itself on our APUs, this will find itself in Intel CPUs, it will find itself on NVIDIA graphics cards. It's absolutely the future of memory for the PC industry as well. Now, it's got some wacky stuff. It's quite different from its predecessors, GDDR, and in particular, it uses something called an interposer, which takes a. I was going to bring up. It's gone. Where's my die? I was going to bring up Antal, and now I will. Antal, my assistant in the sparkly swimsuit. Antal, would you would you hold up the die? So this is the latest die. This is a Fiji chip, but you can actually make out on the rectangle. We can pass it around the audience, so you can pick it up and hold it at some point as well. You see all this packaging. You can see if you look at the underside of it, little dots of alloy which you solder onto the graphics board. But it comes with several layers and is fundamentally very, very different from what we've been doing in graphics boards before. Graphics boards have typically had memory chips which are soldered onto the board in a quite different place. Now we actually stack the memory, it's 3D stacked layers of memory on top of the interposer with a logic die that controls the memory. So we buy our memory from one manufacturer, we buy the interposer from another, and we manufacture the GPU, it's the chunk over here, at TSMC or other foundries. And we put all these parts together, we make a highly complicated chip. And we are the first company that's brought HBM chips to memory, to market. So the Fiji chip is the world's first GPU which supports this. And it has some pretty big numbers. We typically see an advance of 10 or 15 or 20% year on year in terms of bandwidth, in terms of throughput in various ways in a system. Here what we see is a full 60% higher memory bandwidth than the 290X. So the fastest graphics card we had in our previous generation, 60% higher memory bandwidth. That's quite a lot, and very, very much designed to meet and exceed the performance of the most demanding uses at the moment. Now, if I give you a number for the memory bandwidth that's available on this GPU, it's half a terabyte of bandwidth per second. That's a really big number. 512 gigabytes per second of bandwidth compares to typically about the 100 or 200 gigabytes of bandwidth which is available on previous GPUs, peak at about 320 or so. So really, really big jump. Extremely power efficient, which is one of the main reasons why we've done this, because as we've tried to build GPUs and go faster and faster, we find that memory consumes more and more of the power in there. And some crazy big numbers, a 4096-bit memory interface. Is that a big number? Well, if you know about memory, you'll know that it is. It's a full 8 times bigger than the biggest interface we've ever seen on a GPU before. And it allows us to run wide and slow rather than fast and hot. Wide and slow is much more efficient than fast and hot. And it enables some small form factors. We're going to show you 1 or 2 graphics cards today which are